So I was saying this is actually the it is because of these processes which because these processes which are responsible for the beta decay. What I mean by these processes, now for example, you know that in the beta decay process, I said that this neutron goes to proton plus electron anti-neutrino. Now you know that what are the Coriolis constituents of neutron, what are the Coriolis constituents of proton, and these are fundamental. They don't have any they are not composite of anything else. But so I will show you what is actually, as I said, कि इस तरह से मैंने कहा कि this is neutron, it goes to proton, then there is an exchange of W plus minus, and it then goes to what I was saying, electron and an electron anti-neutrino, right? Fine. So this is, so I will just try to explain what is actually जो मैं अभी कहता था W plus minus will couple to W, this will couple to quark pairs as well as the lepton pairs. That I will show you here what is actually happening. So that makes this neutron will go to proton and these two other particles. So what is then? So now you know that. Now I will write down the this neutron as well as the proton in terms of the quark constituents. So let me just make it like. Fine. So this is, I'm saying that let this be a neutron here. So neutron, why I'm showing you three different lines? Because you know that neutron is composed of one up and two down quarks, right? And here I'm saying the up quark will remain as such up, this down quark will remain as such down. But here, as I was saying, this W plus minus जो है, W plus will couple to the D quark. As a result, it will change the flavor. So it will couple to this W plus or W minus. So what will happen? This D quark will be converted to an up quark, right? So we have this propagator W plus or W minus. So it will then decay to an electron and an electron neutrino. So you just see, now you know that what this up and down, this is a Coriolis constant of proton. So comparing these two figures, you just see कि यहाँ पे मैंने neutron और proton जो है, so it is actually this process that is responsible for this beta decay, that one of the d quark from this neutron, and from this neutron is actually coupled to a W plus minus, and it just goes to the G quark. As a result, it will convert this neutron. So in the other, on the other hand side, at the other vertex, we have two up and one down quarks, and we know that the two up and one down quark are the quark constituents of a proton. So this is actually what is happening there inside in this process, in beta decay process, right? Okay. Now what could be the amplitude for such a process? The amplitude for such a process is actually is proportional to amplitude for this particular process. And amplitude means the probability for the occurrence of this particular process. Amplitude for such a process means for this beta decay is always given by GW square, then Q square minus MW square C square. Okay, where GW जो है, this GW is the strength of the NGT, strength of the coupling constant जो है, coupling of W minus. So this GW actually determines the strength of the coupling of W minus with, or I may say, to the quarks and leptons. Yani this GW is constant and it always determines the strength of this W minus to the quarks. So it will vary from one particular case to the another, right? Okay. Now again, and this Q square, what is this Q square? This Q square is actually, we write it as EQ square by C square minus mod of this Q square. Okay, now you might ask, what is this Q square and what is this EQ square? This Q square is nothing. This Q is the momentum, transferred between the neutron. This is the momentum transferred between the neutron and proton. Q is the momentum transferred between the proton and the neutron and the proton, and EQ is energy transfer. EQ is energy transfer. Now, obviously, when something will go from one point to the another, or one system to the another, energy as well as the momentum will be transferred. So the amount of the momentum transferred and the amount of the energy transfer, this is energy transferred and this is the momentum transferred in this particular process when the neutron is going to the proton. Now this momentum transfer जो है Q square, this is total four momentum square जो आप कल भी मैंने आपसे कहा था. Now the momentum transfer square, that is Q square, is of the order of MeV. This is of the order of MeV per c. Q square, let me write it here for momentum transfer Q square, momentum transfer Q square is of the order of this MeV per c. So if you compare the MeV and this GeV, so you will see this MeV is very small, and in comparison to the mass of this W plus minus, the MW and C square. So what we will do, since this momentum, that means the moment of the four momentum transfer square here will be very small, very negligible, and we have the mass of this W plus, which is very high, this mass, which is very high, which is of the order of some GeV, 82 GeV मैंने कहा था आपसे. So then if you compare the 1 GeV, it's like you are adding 0.1 to 100. अगर for example 100 plus 0.1 मैं आपसे कहूँ, you will say approximately it is again 100. You will say this is 100. So then when GeV and 1 MeV, since this is of the order of MeV, so we neglect this in comparison to this particular MWC square, so which is around 82 GeV square. So then how I will write down this amplitude? So instead of writing this Q square here, this amplitude simply, so I will write down the amplitude for this particular process as simply GW square divided by this MW square C square, because this Q square is very small in comparison to the mass of this W plus minus. That is why we just neglect it, and this is the amplitude of this particular process, amplitude for the weak decay process, right? Okay, now one more point here. Since we know that W plus minus coupled to quarks and the leptons, so we can classify these weak interactions as, into three different categories, because as I said, W plus minus couples to what? This will couple to the quarks as well as the leptons. So we classify them into three different categories, okay, into three different types of the interactions. So what are those interactions? But I think I will just log into the another meeting, because this is going to end. I do not want that lecture to get interrupted. ठीक है, मैं फिर से आप because this is going to end in a minute or so, आप फिर से log in करिएगा. So we will just try to I will try to explain all these things. Okay, so we have few minutes left. I will just repeat all these things what I have said in this particular lecture. Those who had joined late, I will just repeat some of the things for them. Okay, so I was saying, since in the yesterday I say that from the Fermi Fermi theory of beta decay, we consider this beta decay in analogy with the electromagnetic interaction, जहाँ पे मैंने matrix elements लिए थे for some electron, this for the electromagnetic interaction between an electron and a proton. So I write down this. So in analogy with that, I write down the matrix elements for this. Okay, so since that interaction, the electromagnetic interaction between an electron and a proton is viewed as a current-current interaction, and this process, this beta decay, that is neutron going to proton plus electron antineutrino, is very much similar to that particular process, especially when I will view this as a Crossel process. So here, like we have in the electromagnetic case, we have the proton current and the electron current. Here I am considering as the two different currents, one as a hadron current and other as a hadron current and other as a lepton current. Then I write down the matrix elements for this in terms of the Pauli's matrices. The matrix, but the only difference between the two, that is the electromagnetic interaction and this, we do not have this coupling is not involved in this particular case. Okay. Okay. So then I say so then I told you actually what is actually happening this in this process, since W plus minus is an exchange of this mediating particle here. So then I say this W plus minus actually couples the quark pairs as well as the lepton pairs, and it is that process that is actually responsible for this beta decay. For example, I said in the neutron we have one up and two down quarks. So one of the down quark will couple to W plus or W minus, and it goes to the up. As a result, we will have this neutron is actually, so that is the actually reason the neutron is being converted into a proton. There a neutron goes to a proton along with the emission. To conserve the other things, we have the other particles, like we have electron and electron neutrino, right? Then this is it. Then I write down the amplitude of this process. So GW by square divided by, then I say Q square minus M W by C square, where you know that this is the mass of a boson. This is the strength of the coupling, yani how much this what is the strength of the coupling between the lepton of the W minus with and W minus or W plus with the quarks and the leptons. So it depends upon the magnitude of the strength of this mediating gauge boson with either quark or the lepton. But this is a four moment of scale, since as I said this is very small in comparison to this mass, because this is in GeV and I said this is in MeV. So I simply write down the amplitude of this particular process as GW square by MW square C square. So this is actually the amplitude for this particular process to happen. So if you can find out, if you know the GW and mass of the mass you already know, you can find out the amplitude for any of the processes, any of the weak processes that are there. Now, as I said, there are, depending upon whether W plus minus will couple to the quarks or the leptons, we actually categorize them into three different classes. One is what we call as a leptonic decays, or leptonic weak decays. Then there are semi-leptonic weak decays, and then there are non-leptonic, जिनको हम hedronic decays भी बोलते हैं. Now, in the next meeting, I am going to discuss about those. That is very actually very simple concept. So okay, now if you have to ask anything about this particular thing जो मैंने अभी तक कहा है, or if there is some point where you have any doubt, you can ask.